Okay. Let us give 2 more minutes, and then we're gonna start here. And I would kindly ask you to keep muted, and then what we want to do is start the presentation, and then we're gonna basically have a Q&A session at the end, and before that we have a little panel discussion, and I've invited a couple of panelists, and so we're gonna start in a minute's time from now, and then I'm extremely happy and thankful that you all joined us here. We are hosting this webinar from both the United States, where I am, and from Cyprus, where the headquarters of EDAMS is. So you still see people coming in here, and so 2 time zones here in San Francisco. It's morning, and Lucas here in Cyprus is evening. And then we have other participants from the United States and from Europe and from India and the Middle East. And let's start here. Thank you so much for attending our webinar, Unifying Solar Data, Monitoring and Lifecycle Performance. And I've invited my 2 colleagues and the CEO of EDAMS to speak to this subject. I would like to first introduce Dr. Dinos Konstantinidis, who has worked for many decades on this issue, and working from the water side of things to the energy side, and has long ago, over 20 years, over 40 years, seen and perceived that the integration of data is so extremely important to optimize large-scale assets. And Dr. Dinos, could I please introduce yourself? Would you speak a couple of words, please? Thank you.
Thank you, Folkman. Can you all hear me well? Folkman, can you hear me?
Yeah, we all hear you very well. Thank you.
Well, as Folkman said, I've been around for a very, very long time. Just to give you an idea, I'm 68 years old and got my PhD in engineering when I was 24. So I've been in utility management one way or another for well over 40 years now. I started the company about 35 years ago in South Africa. That's where I studied, and I was I ended up being a professor in water engineering before I started the company. Written a few books, and then I decided that academics wasn't for me, and that I had to put everything in practice. And as Folkman said, we started off with the engineering part regarding infrastructure, and very soon we realized that engineering wasn't good enough. You had to introduce a lot more aspects into it to be able to address real issues facing utilities. And slowly over the years, we developed more, and we integrated more. And at the end, we landed up having a full, what we call an ERP for utility management, which over the years, we made industry specific. We started with water and sanitation. And then we moved into other areas. We expanded to cover all municipal services, went into electricity, and the last 5 years went into renewables. We were lucky enough to have a very big customer, basically the biggest private electricity operator in Cyprus, that entrusted us, liked what we had, entrusted us to adapt it for renewables. So what you're going to see today has been implemented in practice. And the beauty of it all is the integration. Whenever I spoke in conferences or in shows, people all over the world told me, yes, we got this and we got this and we got this, but it's all different software suppliers. And we have to integrate and link and do some work in between to process data and information. So what you're going to see today is something that's been tried out for quite a few years in other utilities and for the last 4 or 5 years in the energy sector as well. And it's pretty nice. I hope you'll enjoy it. And
Thank
I'll
you
be
so much.
around most of the seminar, and then I got a flight to catch.
Thank
Got
you. Thank you,
meetings
Dino.
tomorrow morning and meetings on Friday
It's great.
with a water utility tomorrow and with an energy utility on Friday. So I'll hang around as much as I can, and then I have to drive to the airport.
Lucas, would
Thank you
you
all.
like to
Yeah, sure. Hello,
shortly
everyone.
introduce yourself?
Hello, everyone. My name is Lucas Pikolos. You can call me Lucas. For the past years, I have been working as a product service manager at Adams Technology. My background is in electrical and computer engineering with a focus on energy market management systems. From the early year of my career, I have worked with renewable energy sources like solar parks and BESS systems, battery energy storage systems. Before we begin, I would like to thank the Vice President of Adams Business Development, Porkmar, for organizing this panel and creating the opportunity for an open discussion. The webinar will explore how unified solar data and performance intelligence can drive a stronger return of investment across the solar projects and their market participation lifecycle. The session will begin with the key industry challenges, including the return of investment hurdles faced in projects and the role of unified data in overcoming them. The webinar will highlight the value of real-time monitoring, performance insights, and life cycle performance management in optimizing operational and financial outcomes. The discussion will continue with a look at how these strategies can translate into direct ROI impact, followed by an interactive panel discussion featuring expert perspectives. And the session will conclude with an open discussion, allowing attendees to ask questions, share experiences, and engage directly with the speakers.
Yeah, so when I thought about the subject, my first thought was about what is the strategic context here? Yeah, I mean, we're talking about technology deployment, we're talking about performance of this deployed. And the main problem I kind of saw is having a bird's eye view on the global market, that capital and technology are largely available, but the outcomes depend on how the assets are operated, how they're integrated, and how they are connected to markets. And for investors and operators alike, the operational performance is not a secondary consideration. It's a primary driver of realized returns. And the variance in execution translates directly into cash flows and returns for the investors. So execution extends well beyond just the construction and the delivery of these renewable energy assets. We need the data, the digital integration, and the operational handover, and the capability to manage the assets continuously across the full life cycle. And if this is not being done in a proper way, the returns that have been promised to investors are not properly realized. Next slide, please. And that global context in numbers, and these are approximate numbers, solar is no longer a marginal technology. It's a 1.6 terawatt of installed capacity worldwide and has become a core institutional asset class. And at this scale, even small operational efficiencies become economically meaningful. If we could assume a 3 to 5% portfolio level performance leakage, that would result to 7 to 15 billion euros in annual value decrease. I mean, that's a massive number. And that leakage is predictable. It is not only driven by technology failure, but also by how assets are operated. Often we have a lot of fragmented data, delayed issue detection, and weak integration between operations and markets. And crucially, this performance drag is largely underpriced at underwriting, and the returns are modeled at financial close, but the value is lost during operation in ways that are not necessarily systemically controlled or reported. So this is one of the meaningful problems that has to be addressed. And the implications are very clear. As the portfolio scale, the operational execution becomes a primary determinant of the realized returns. And that's a gap we are addressing. Next slide, please. And the common thread of this is fragmented lifecycle execution. Data accountability and decision-making are spread across development, delivery, operations, and market participation without a single end-to-end performance owner. And when this data is fragmented, forecast variance is detected late, issues remain unresolved for longer than necessary, and the operating costs rise because maintenance becomes reactive rather than condition-based or proactive. And over time, these small operational gaps can turn into persistent performance leakage and higher cost and greater cash flow uncertainty for both the operator and the investor. And the fragmented execution also makes it harder to clearly demonstrate the performance and the value to the stakeholders. And that affects investors, lenders, regulators, and partners. And that lack of visibility also widens the gap between expected and realized returns. So again, to summarize this is not a pure technology problem. It's a structural execution problem that sits at the core of underperformance in return on investment. And the solution to these issues that have been raised is now presented by Lucas.
Yeah, exactly. Totally agree with you, Workman. So following to the key information provided by Workman, it's the fact that across the solar industry, we are entering a critical phase. a phase where solar plants are scaling faster than our operational systems can keep up. And many energy utilities nowadays manage hundreds of parks, yet their data still lives in disconnected and isolated systems. For example, production data sits in inverter portals, meter data sits in MDMS systems, weather data and variables that can be controlled on SCADA systems, asset hierarchies in engineering spreadsheets, and the most important, commercial and demand data lives in billing and CRM platforms. All this information is essential, but none of it speaks the same language. And what does this mean? It means losses, as Volkmar said before, stay hidden. Decisions slow down, maintenance becomes reactive, reports don't match, and ultimately return of investment is suppressed. Think of a solar portfolio like a human body. You can have healthy heart, you can have lungs, muscles, but without a central nervous system coordinating everything, you lose efficiency and responsiveness. Most solar portfolios nowadays operate without that central nervous system. So return of investment is directly affected from, as you can see on the slide, fragmented data across the life cycle, from underperformance versus forecast, from delayed issues detection, from rising O&M costs, and from difficulty providing value to stakeholders. These are the main categories. Different systems use different data structures with naming conventions and assumptions to be necessary. This leads to mismatched asset IDs, duplicated records, and conflicting performance metrics, making it hard to trust the data that drives operational and investment decisions. And these inconsistencies also cause billing and settlement discrepancies, resulting in market penalties and a lot of times to system imbalances. Now let's move to the terminology used in our today's presentation. What unified solar data means that all technical, operational, and commercial systems, like, for example, solar park development, solar park asset management, O&M platforms like solar park operations and control center, MDMS system and utility billing and CRM, energy trading platform and business intelligence dashboards for park owners and utilities, operate on a single shared database and data model. In this way, eliminates internal integrations and data silos, creating one real-time source of truth across the entire solar asset life cycle. And let me explain the ideal solution we propose. Most platforms in solar industry talk about integrations. We take a different approach. The solution is built on one single database that all software systems operates on, like what we said before, billing and CRM, energy trading, monitoring and control, O&M platforms, asset management. All of them, they are working on the same data model in real time. And this is a fundamental difference. In a typical setup nowadays, each system has its own database, as you can see on the slide. Here we can see all the necessary software an energy utility needs to utilize in order to support its operations and properly participate in a final energy market. Data from energy production and storage units are collected through dedicated portals and transmitted to RTU loggers. Consumption data and certified production data are stored in MDMS systems. And these data are then used by the O&M platforms, such as the control center for real-time monitoring and control. And the same datasets are also consumed by billing and CRM systems for billing purposes, as well as by energy trading platforms for demand and production forecasting. Furthermore, energy trading platforms complete balancing functionality and generate all required XML files and submit them to the market management system and governmental market management system. And based on these submissions, the market management system sends back the market schedule. Following market scheduling and the generation of the park production program or any renewable source of energy, these programs are sent to the on-them platforms so to be executed. To operate effectively in the energy market, we need coordination across all these systems. On top of that, monthly reconciliation and billing for both customers and producers are absolutely essential and simply cannot be skipped. When you look at the whole picture, I think it's very clear that this end-to-end operation requires very strong system alignment. You really can't rely on assumptions if you want the results to be correct. From experience, it's fully understandable that more integrations points you have, the higher the risk is. And when you minimize those risks, the accuracy of the results improves significantly. In our case, instead of spending hundreds of hours managing integrations between billing and CRM, between energy trading platforms and O&M systems, we choose a different approach. We made all these systems operate on a single database. By doing this, we avoid complex integrations and work with one clear source of truth. And this not only simplifies operations, but it also helps us to reduce undetected losses and improve overall accuracy and control.
Just before you change the slide, Lucas, can you go back? Items 1 to 6, which is locking all the way to controlling the renewables, the parks, whatever, the wind or PV or whatever, can actually on EDAMs can run automatically. It can actually, it's so well defined, the workflows, not just that they're sharing a database, but the actual workflow step-by-step basis of doing all those actions. Like if somebody doesn't want to operate it, if one of the operators doesn't want to get involved, say it's Sunday and he wants to go home, you can put it on auto and it can all run. So that's how far we got in terms of the power of this integration. So it's not a matter of just sharing the database. It's all the workflows are all worked in on the steps from the day before to the actual day of operation to the day after. And the cycle is repeated and the information is not lost, is kept in history in the database. So if you're going to go back and produce not just for reconciliation purposes and billing purposes, but if you want to go back and query any type of data, it's there. Thanks, Lucas.
Thank you, Dr. Dinos. So welcome.
Yeah, so basically on a real case basis here, and we have proven that a portfolio-wide performance visibility on an operational level and the whole variance detection contributes a lot to the performance loss recovery. And we have measured that in a 100 megawatt portfolio, that the annual revenue recovery is about 900 to 1 million euros, which translates to approximately 2% of previously undetected losses. In this case, 2.5 to 3.5 thousand megawatt hours. I think this is also tying into my first assessment of the losses that are accounted for over the whole world, and we're rather conservative here in our assumptions. And this massive impact is due to the O&M optimization through the data from condition-based maintenance and unified for diagnostics. And I want to put out the word unified again, because this is really the difference. We're not working with spreadsheets and then integrating spreadsheets at the end of the day. The whole system has several interfaces where workers then put the data into one system, and one system creates the numbers so you can make operational and management decision making on the full data at real time. Also contributing to this financial outcome is 20 to 30% reduction in preventative maintenance visits and extended inverter lives, obviously, by 1 to 2 years. And as we know, lower life cycle O&M costs are the result of that, and CapEx is deferred. And since we are a full life cycle instrument, meaning from commissioning to trading, this software, this platform also addresses market penalty mitigation, because the integrated operational and market data is centralized with a TSO interface, which then also improves the forecast and accuracy and imbalance exposure. And as a result, the company recovers additional cost by having reduced penalties and much more stable merchant revenue. So this whole complex view, this integration of data and utilizing data along the whole life cycle of the customer is significantly improving operations and financial results. Thank you. I give it back to Lucas.
Dr. Dinesh, you want to say a few things?
Yeah, okay. Basically, what this slide shows is the different features and the different type of vendors that cover those features. Basically, there's three type of vendors that provide software right now that energy utilities utilize. There's the O&M vendors that concentrate basically on maintenance, and there's some pretty good ones that do both reactive, predictive, and preventive maintenance, and they handle operations pretty well. It's a matter of finding false alerts and doing analysis for energy losses. And most of them have a control center where they can control the switching on of the parks. And they do have some business intelligence, basically limited to the O&M functions. And then the second lot of vendors have a market trading platform, excuse me, or market trading software, and they're pretty good in doing that as well. There's some quite advanced trading platforms that, especially in Europe, where they can trade in multiple energy exchanges. And then you have the billing vendors. They're the people who concentrate on doing billing and customer services or customer or CRM or whatever you want to call it. And that's what EDAMS does all of that, all in an integrated manner. On top of that, it's got a full GIS running behind it. So you have the geographical part on it, which none of them have. unless they utilize something like Esri, which is a pretty standard GIS system used, especially in the United States. And they have, so you can actually put a fourth category here of vendors that we cover. And this is the beauty of it. I think Lucas has a slide where he shows the different modules of VDAMs that do all that, the integration after that. This slide here. Okay. Basically, that's all I wanted to say, Lucas, on that.
Okay.
But that basically, go back to that slide I was talking about. Well, this slide is basically comparing what is out there with what VDAMs can do. There are some vendors that say they can do everything, or at least they can do O&M and billing, like Oracle and SAP, but they're quite complex systems and they take they're quite expensive, both in terms of licensing and in terms of implementation. And then usually not industry-specific systems, so they do take a long time to have them up and running properly, and a lot of costs. But apart from those two, the rest are all fragmented in these three main categories. Okay, Lucas, thank you.
Thank you. So thank you so much, Lucas and Dr. Dinos.
I think, sorry, Fogman, I think before you switch off, Lucas, show them the slide with all the different modules so they can see what they're all about. That other slide that you showed, this one here. Do you want to talk about it or you want me to talk about it?
Whatever you prefer.
Excuse me?
Whatever you prefer.
Let me say a few words quickly about each one of them. All these round things are the different modules that, as Lucas said, they all share the same database. We have a module for development. So that's like licensing and permits and inspections and stuff like that, a step-by-step process for the development. As you know, it can be quite complex, especially with environmental studies and licenses and all that sort of thing. Of course, this might vary from country to country, and our system will have to be changed a little bit for each country. Then we have asset management. Asset management has a lot of modules in it. Do you have that slide that shows the asset management breakdown?
No.
No. Basically, what it has, it's got an asset register, industry-specific asset register for the infrastructure. And that's infrastructure both in terms of energy and in terms of electricity distribution, because you have electricity distribution components as part of it. It's got a full maintenance management system that includes even a call center, even a mobile app for interaction with the public or somebody else for calling problems in. And it's got an asset management planning module, as most commonly known as rehabilitation planning, as in terms of addressing aging infrastructure, which might not be a big issue in renewables right now, but it's starting to become an issue as some of the parks are getting older and older. And operations is basically your logs. You're logging there directly to the inverters, not to the RTUs of the parks. And through doing analysis of the data, that's where you're finding most of the faults. Well, the two types of faults, that's alerts and faults with regard to breakdown, and other faults that are more hidden that can manifest themselves in terms of energy losses, in terms of production. So there's full analysis being done there to be able to, for every string going back, a group of strings going back from each inverter, to be able to identify the type of losses for each part of the park. A control center, it's something that controls the park. It helps you can see it and monitor it. You can switch it on and off. In our case, what differs in our solar park control center from other control centers is that our control center also links to the market or to the TSO. If the TSO gives instructions, for example, in terms of curtailment for a specific aggregator, usually TSO gives instructions on various aggregators. The control center takes over to redistribute energy production in the parks to be able to cope with those instructions. So a big difference of our control center with others is that it can be used like the other control centers are used, but ours also communicates directly with the market. So on a real-time basis, it readjusts energy production. On the bottom side, we have the meter data management system. That's a system that collects all the information, either directly from the meters or from a meter data management system of the DSO, as it happens in Cyprus. They have their own MDMS system that they get all the consumer meter data and also all the production data. And we link to that to download basically on a real-time basis all the information in our systems. Then we have a full utility billing and CRM system. This is quite a system we've had for years now. And it's web-based and pretty advanced. Just to give you an idea, more than 50 million people are being served by utilities with our system here. And then we have the energy trading part, which Luke has explained a little bit. We have two versions of that. The one has to do with what we called in Cyprus a temporary or transient market. They were trading on a monthly basis. And the version that trades on the day-ahead market. In Cyprus, they're trading on half-hour basis, but that's a setting in the system that you can change depending on the country and what you have. And then you have business intelligence, which is a lot of dashboards, which is published in the form of a utility management portal with different hierarchies and different access rights. For example, you have stakeholders looking at certain dashboards, you have the CEO looking at others, directors at others, people head of operations at others, people head of commercial at others, and even lower down as it goes lower down to supervisor level. Very intelligent system. It's a drill down system. So you can drill down from anything to go down to the source of particular path of information. And we have two versions of that. The one is for the producers themselves, because they look at only part of the information and in a specific manner. For example, the producers can see the reconciliations and the payment from the utility, the financial side, plus the production, the packs and so on. And then you have the full utility management portal that has everything. I think in one sentence, if I can describe the system, I would call it, as it says here, the ERP of renewables without enterprise complexity. Thanks, Lucas. Just to give them an idea of what it's all about. You know, it's actually a lot of different independent systems, but they don't interface with each other because they use the same database, so they use each other's data at any specific time to do whatever they have to do.
Thank you, Dr. Dinos.
Thank you. So I want to start a little discussion here.
Bogman, before you start,
excuse me.
Before you start, can I say thank you all for coming to the webinar? You're gonna have to excuse me. I have to go to the airport. It's been lovely seeing you. I look forward to hearing from some of you in the future. Bye.
Thank you, Dr. Dinos. Bye bye.
Good luck, guys. Bye.
So yeah, I would like to invite now Simon. Simon, could you please introduce yourself a little bit, your background, and what you've been doing in the industry in the last years?
Yeah, sure. Hi, everyone. My name's Simon. So I've been in renewables many years and worked across the whole life cycle of assets, both wind and solar. So very much have experience of the fragmented siloing that was mentioned right at the beginning of the presentation. So my main work through all of that has been really kind of focusing on, as we kind of drill down to it, is helping investors and operators close that gap between their budgets and what's actually happening on the ground, that real life performance. So in particular recently, I've been doing a lot of work with working with portfolios with all this fragmented data and trying to improve that that kind of visibility of the data, but also enabling people on the ground to be able to act upon it, and then be able to kind of so that then clients can see what's going on, improving, able to improve their performance. So yeah, I mean, ultimately, I'm just very passionate about helping assets perform reliably.
Thank you, Simon. And I understand you overlooked one of the biggest solar portfolios worldwide in the past, spanning several gigawatts in operations. So my question to you is, what from your practice and the lifespan of your career, where did you see the hidden losses? Yeah, I mean, where did you see where did you put on the lever to avoid these hidden losses?
Yeah, so I think, I mean, you'll probably find me repeating some of the stuff you've already said because, you can talk about individual things like degradation, soiling, inverter overheating. These are all things that that we know that are causing losses. But at the end of the day, it's the biggest thing is just that what's hidden. Um, because we've just got unreliable data, or it's data that's all over the place. As we said before, we had before, in SCADAs and loggers, meters, O&M platforms, spreadsheets. Still, unfortunately, there's a very little standardization, and being able to kind of bring it all together in one place. Even across the life cycle. We saw that from development through construction to operations. These are all like little silos, and quite often the data model stops when it goes into the next one, and a new one has to be built up. So it just means that we kind of then just are losing that visibility of everything that's going on. So the underperformance is usually not a mysterious thing; it's just invisible to us, because we haven't got that kind of integrated data. It's all fragmented all over the place. So kind of bringing that together is where we can then really start to see where we can not just operational performances, but also, like Lucas was talking about in terms of on the trading side, the financial side, the markets, that it's having that ability to kind of see it across the whole plane.
And if you would, let's say, if you would pinpoint to one specific discipline that would directly improve return, what would you say this is? And
Yeah.
oh,
I mean, obviously there's a few things that we could talk about. I mean, it's like forecasting is a massive one. I mean from my background, it's much more in the kind of technical O&M and asset management space. So I am more familiar with the kind of kind of condition monitoring based side of things, where you're when it works, when you are getting good data and you are able to kind of be proactive with your maintenance, as you've shown, and I've seen, firsthand and in other case studies, you can reduce the number of visits, sending guys out to, to sites, reducing that cost in truck rolls, and also on these really big sites, being specific is great as well. you've got many hundreds of megawatts solar farm, and you've got, oh, it's in this kind of, it's related to this inverter block, which has got, you know, thousands of panels connected to it. It's going to be pretty hard to pinpoint where that is. So they're all like really kind of beneficial aspects that you can add, you know, along with then all the other side of things, like you're maintaining and being proactive, you're extending the life of the inverter, you're just bringing that OpEx cost down. You know, and if you can automate that, getting a good data model, it then makes it, you know, cost effective to do it.
Okay, thank you. And I mean, do you feel or do you really think that it's important to integrate all the data to have one source of truth, and how in your daily or operational work from your operational perspective, how do you see this playing out? I mean, in terms of improved operational execution.
Yeah. I've worked with platforms where you've got one source of truth and ones where you really don't. And when you don't, you're spending most of your time troubleshooting to find out, well, why is my data in my report different to what it says on this dashboard? Or I know these things happened on site because I was logging people in, but it doesn't seem to, the number doesn't seem to really look right. So you spend all your time troubleshooting, and obviously you don't look good in front of your investor or your client either, rather than spending your time acting on the data and, you know, but doing more cool things that can help dig into the data more and find out more insights that, you know, previously you couldn't. So yeah, I think that's the real, you know, from a practical point of view, where I've seen, you know, where having that one source of truth is really beneficial.
So thank you so much, Simon. And I think now I'm opening up the room here for Q&A. Do you have any questions to Simon or Lucas or eventually me? Is there anything you would like to bring up? And you can unmute yourself and put your camera on if you wish to do so.
Yes, Workman, thanks for this nice webinar. I have one question. Nowadays, every inverter is inbuilt their on what to say IoT based platform. Every inverter is having their IoT based platform. How you differentiate from them to identify what exactly you are solving?
Okay, Lucas?
Can you repeat the question, please, Ashar, because you mentioned water.
Because every inverter is having their IoT based platform where we log in, we give credentials, and they are having their dashboards and all these things, or how many units are generated, how strings are performing, and how you differentiate from them to your software.
Well, the biggest advantage in this case is that, I mean, the example you gave is just for the control center, for monitoring and controlling PV parks, right? Correct?
Yes.
So I brought this slide on. This slide shows the complete solution and the combination of all the connectivity actually between several components. Well, other competitors can show dashboards with real-time metering and controlling of the parks. Our advantage, I believe, is that the control center we provide is an advanced monitoring and controlling center, which not only provide to the user the ability to monitor and control the assets, but also provides the ability to participate to a final market, to automatically respond in case of TSO, transmission system operator instructions, or flag distribution system operator DSO controls. And this is very important because you can then do some reconciliations and say why there is such a lot of curtailment to these parks and so on. You can make a lot of find out a lot of results and in general have a good idea of what's going on to your assets. This is the first one. The second one is that you can monitor PV parks. You can monitor batteries base that are installed in PV parks. The control center will, if you participate in a final energy market, the control center will take care of the PV plant, so produce so to follow the schedule generated a day before, the park production program, we say in terminology. And the same goes for wind turbines and biogas turbines, as you can see. Here, essentially, we can see the connectivity between the systems and how all this data can be received by the control center and used. So the market operator or the PV plant operator to have a real-time image of what's going on to his assets.
Okay, yeah, thanks. But I have another question. How you retrieve the data from solar plants?
Currently, where each solar park, all inverters of one solar park are directly connected to an RTU. An RTU is a remote terminal unit where we connected through the control center to these RTUs through IEC 60870 standard of communication, and we are able to receive information and send commands as well. I think I have a slide as well showing the control center just to have an idea.
So it's not about the software, it's about the components as well.
Yes.
Okay. Yeah. Yes.
This is the control center as a screenshot from the user interface. You can see live measurements of PV parks like in graphical representation, in geographic representation. You can see the state of charge of the battery and multiple information about where is the park in real time, the active power produced, the capacity of the battery at both park, the radiance availability, the curtailment, if someone is applying curtailment, who, for this case, is distribution system operator. And we can have more information like the specifications of the battery that it is installed and how many panels are there, the brand of the inverter, and so on. And you can export information and can go back and see history and do some reconciliations as well. This is just some screenshots of the control center we offer as a service.
Thanks.
Welcome.
Well, thank you so much. I think, are there any other questions? So if not, we're concluding this session. I just thank you so much, Lucas and Dr. Dinos, and of course, Simon. I extremely appreciate your input as a veteran of the industry, and I will also make sure if people have questions further on this or other issues to include you in the follow-up. Thank you so much, everyone, for attending here. If you have any questions going forward, please reach out to us, and we'll be extremely happy to answer them. Thank you.
You can also find us on Intersolar in San Diego next month.
Exactly, yeah. So we're gonna visit Intersolar in the coming weeks. So if you wanna meet us in person. So
Okay.
thank you.
Thank you all.
Yes. Thank you.
everyone.
Thanks.
Thanks for your information and time.
Thank you.
Have a nice
Bye.
day, night. So
Yeah.
bye-bye.
Thank you. Bye.
Bye. Take care.